This is the third of 4 videos that I've made for solving trigonometric equations. If you have not watched the first 2 yet, I'd recommend that you start there. This video in particular deals with a new issue where we're going to solve a trig equation on an interval. And we're going to figure out how we can change our formula to figure out which values actually live on, in this case, 0 to 2 pi. First step that we always want to look at for solving a trig equation is to isolate the trig function. And in this case, we have the tangent of our argument is equal to a number. So that step is done for us. And then from there, I want to think of the argument as a big angle. So I'm going to call it theta for a second. So what I really want to do here is find what angles theta on the unit circle correspond to a tangent of square root of 3. So when I finish that, I'll have 3t minus pi over 6 is equal to some values here. So looking at the unit circle, I know that the tangent is equal to the square root of 3 for the angle pi over 3. So I'll get this guy. From here, I know that the tangent has a period of 1 pi, meaning if I add pi to this, or a half revolution, I'll end up in quadrant 3 at another location that has a tangent of pi over 3. If I add another pi, I'll end up back here. So what's nice is my angle, or my argument theta, corresponds to pi over 3 plus any number of periods, or half revolutions in this case. So once I've solved for the argument on the unit circle, I then have to come back and solve for any variables that are inside of it. So I need to solve for t. To do that, I will add pi over 6 to both sides, and I want to keep in mind that I'm going to add constants to constants here. So I'm going to add pi over 6 to pi over 3. To do that, I need to think in terms of a common denominator. Pi over 3 is equal to 2 pi over 6 plus 1 pi over 6 would give 3 pi over 6, which is just pi over 2. Still plus pi k. To finish solving for my variable, I'm going to divide both sides by 3. That will give me t is equal to pi over 2 divided by 3 is 6 plus pi over 3 times k. So this is the formula that we need to find all of the solutions that are on 0 to 2 pi. And the way that I want to think about this now is to just start with that first value that we have there, pi over 6. Once I have pi over 6, I can add any number of pi over 3's to this. So it might be useful to remember that pi over 3 is the same as 2 pi over 6, and I can keep adding 2 pi over 6 until I get a value that is more than 2 pi. So if I think in terms of sixths again, 2 pi is equivalent to 12 pi over 6. I'll just keep adding 2 pi over 6 until I get beyond this. So pi over 6 plus 2 pi over 6 is 3 pi over 6, 5 pi over 6, 7 pi over 6, 9 pi over 6, and 11 pi over 6. If I add another 2 pi over 6, I'll get to 13 pi over 6, which is too large. And I could also go backwards, but if I subtract 2 pi over 6, I'll get a negative value. So I get 6 solutions on 0 to 2 pi. And the last thing that I should do here is to remember that some of these can be simplified. So for instance, 3 pi over 6, I should probably write as pi over 2. And also 9 pi over 6 simplifies to 3 pi over 2. So then I get 6 solutions, pi over 6, pi over 2, etc.